Okay, now we're getting into using permutations and combinations to solve for the probability of an event. So what we're going to do here, let's just remind ourselves what probability is from the last unit there. Probability is equal to favorable over total. So now what we're going to do is we're going to use our counting methods, whether that's permutations or combinations, just to figure out what our favorable is, like how many ways something can happen for our top, and then how many ways something can happen for our bottom. And that's pretty much it. That's like the new part of this. We just need to solve like the number of ways something can happen for both those situations. So here's an example. So it says a 4-digit PIN number is selected. What is the probability that there are no repeated digits? Okay, well, all we have to do here then is figure out, well, the favorable, right, the one on top, would be your number of ways if there was no repeating digits, right? So pretty much the question, like there's like two questions here. One is going to be how many ways can we have repeating digits, or sorry, no repeating digits on top? And then on the bottom, that's just going to be all the ways. Okay, well, that's not too bad. So in that case, what that would be, the number of ways that we can have like no repeating digits. Let's just remind ourselves that we do that. If you made 4 blanks, if you weren't allowed to repeat those digits, then in the first spot, there are 10 possibilities because the numbers are, 0 to 9. So there's 10 of those numbers. So there'd be 10. And then the next one would have to be 9, and then 8, and then 7. Right? If you multiply those all together, that's our favorable. That's our top number. That's the number of ways that we can have no repeating digits. And then if I just divided that by the total, right? So the total in this case is just going to be, we don't care, right? They can repeat if they want. So in that case, that would just be, you could do it again if you wanted, 10, but then the next one's going to be 10, and then 10, and then 10, right? And there are just different ways to write this, right? So you can see over here that they wrote this as, okay, of the 10 different digits to choose from, we're going to pick 4, right? That's the same thing. That's the same thing as saying this. Of the 10, we're going to have 4 spaces, pretty much, is what that's saying. Okay, so 10p4. Yeah, so we'll leave it like that. And then over, and then on the bottom, that would just be, well, you can write it like 10 4 times would just be 10 to the power of 4. And then putting those numbers in, and then you end up with 0.504. And remember that that could be written as a percentage. You just multiply by 100 or move the decimal 2 times over. That would be 50.4%. Okay, moving on. All right, so another kind of probability question. Well, they're all kind of the same, right? We're just finding the number for favorable on the top and then total on the bottom. That's all that's really happening here. But if we look at this situation, it says in a certain state's lottery, 48 balls numbered 1 through 48 are placed in a machine, and 6 of them are drawn at random. If the 6 numbers drawn match the number that a player had chosen, the player wins $1 million. In this lottery, the order the numbers are drawn in doesn't matter. Okay, that's kind of a key word there. Doesn't matter in the order that we draw them in. So are we thinking permutations or combinations? Yeah, combinations, right? So it's going to be one of these. That's why we got C's down in the bottom there in the answer. Okay, so compute the probability that you will win the $1 million prize if you purchase a single lottery ticket. All right. So now, in order to, we can figure this out. This kind of just explains the same thing, but I'll just explain my own words here. So really all we got to do, again, is just favorable. So probability is equal to favorable over total. All right, so our favorable in this case, though, would really be, well, okay, so we're dealing with like a group like of 6, right? Like, so like as long as I get those 6 numbers, doesn't matter on the order of them, then I'm good to go. So how many ways are there to pick those exact 6 numbers? Well, there's only one way, right? I have to pick those 6 numbers, right? So that you can think of it that way. Or you could think of those 6 numbers, 6 numbers, I'm going to choose all 6 of them. So you could write that as 6C6. But that really is just 1, right? So I just want you guys getting used to seeing it this way as well. Okay, so 6C6 over, and then, so that was the number of ways that the favorable outcome could happen. But then now the number of ways the total outcome could happen. Well, that's just going to be of the 48 different balls, right? So of the 48 different balls, we're going to choose those 6 balls, right? So how many ways can that happen if we have, oh, sorry, not those 6. Of the 48 balls, we're going to choose 6 random ones. And how many ways can that happen? So that's a lot bigger number, right? So that ends up being 1 over that large number, right? And then you can see that we get approximately this number for our probability, which is really bad probability, right? Yeah. I guess it would be quite so bad. It would, because we can move the decimal place over 2 times, so that would be 0.0000815%. So not that bad. Okay. All right. Looking at this one though, it says in the state lottery from the previous example, if 5 of the 6 numbers drawn match the numbers that a player has chosen, the player wins a second prize of $1,000. Compute the probability that you win the second prize if you purchase a single lottery ticket. Okay, so in this situation now, same idea. Can you see that in the bottom our total is going to be the same, right? Because either way, we have 48 balls and they're going to choose 6 of them. So that's the number of ways that could happen. But then on the top, it's going to change because, well, we're going to have two things going on here. So we're favorable. We're going to have, of the 6 balls, we're going to choose 5 of them correctly, right? You're going to choose, like, how many ways can I choose 5 of those balls? And then all we have to do after that, though, is you have to multiply what's left, because we've got to choose one more ball, right? So of the remaining, like after we've chosen those 6 balls, right, of the 48, then there would only be 42 balls left to choose from. Oh, sorry. Yeah, so after we've chosen, here, let's start over, sorry. Let's say, so of the 6 balls, of the 6 correct balls, we're going to choose only 5 of the correct balls, right? And then I only have 42 left to choose from because 6 of them were correct, right? And I didn't choose the last correct one, so there's only 2 to choose from there. So it's going to be 42, and then I got to choose the last one there. So you can think of it this way, that we've broken it down where this one is like our correct balls, and this one is going to be our wrong balls. Yeah? So of the 6 correct balls, we chose 5 of them. And then of the wrong balls, there was only 42 wrong balls, right? Because there was 6 right balls. So we had to go 48 minus 6 was 42. We chose 1 wrong ball. So that's a good way to think of this. Just divide it up as correct and incorrect or wrong. And then that's just going to be, again, over our total of all the balls and then only choosing 6 of them. Okay. All right, so let's do this one. So it says, a multiple choice question on an economics quiz contains 10 questions with 5 possible answers each. Compute the probability of randomly guessing the answers and getting 9 questions correct. All right, so let's get our bearings here. Let's write down like 1 to 10. So 1, 2. All right, so those are my questions, let's say. Okay, so remember again, it's going to be favorable over total is what we're after. So the total part, if the question was just how many ways is there to answer these questions, so if there's 10 questions and each of these has, 5 different like multiple choice spots, right, like bubbles to fill, then that would just be, well, 5, right? There's 5 ways to do the first one and then 5 to do the next. So that'd be like 5, 5, 5, 5, and like 10 of them, right? So our total, our bottom number here would just be 5 to the power of 10. Okay, so that one's not too bad. So that's like a lot of ways there. Now, if we want to figure out the number of ways of randomly guessing and getting 9 questions correct, it's actually going to be easier if we kind of think about this a little different. Why don't we change this to getting 1 wrong, right? How many ways can we get 1 of these wrong? Okay, well, if we look at the first spot here, just focus in on this one. So let's say, you know, that was the right answer in that one, that bubble, if we were bubbling this in. Well, can you see that there's actually 4 different bubbles? Like in that case, if that was the right answer, there's 4 that are wrong in this case. Okay, well, there's 4 that are wrong in that case. So here, I'm going to write that down. It'll be 4. And then there are, well, we could get this question wrong, or we could get this question wrong, or this one, right? We could actually get any one of these questions wrong. That could be the one that we do, right? So there's 4 possibilities for this guy. And then I have to multiply that by all, because it could be this one, it could be this one, this one, this one, this one. It could be all 10 of those, right? So it's just going to be 4 times 10, right? So there's going to be 40 different ways that we could be wrong, okay? Because that'd be the same thing as being right on 9 of them, right? It's just going to be a lot easier to go about it this way than to go about the other way. So in the other situation, we'd have to add them all up, right? All those different cases. So let's just finish this. So this would just be 40 over yeah, big number, 9,765,625, which is we'll just round that to 1. Okay, and that's written as a decimal, right? So as a percentage, we just multiply that by 100, right? So that would be the same thing as 0.00041%. So yeah, not very good odds of getting 90% on that test if you just guess at random. Okay, so I'll let you guys kind of look through these ones. I'm gonna skip down to the try it now one, because it's going to be, you know, a similar question here. All right, so this one says compute the probability of randomly drawing 5 cards from a deck of cards and getting 3 aces and 2 kings. Okay, so probability is equal to favorable over total. All right, so let's figure out our favorable here. So our favorable, let's just do it for each now. So what's the probability of drawing, what's the probability of getting 3 aces? We'll just do that one first, right? So the first thing we're asking ourselves, though, is does the order matter, right? Because I could use a permutation or I could use a combination. And it doesn't really matter, right? Because 3 aces are 3 aces. It doesn't matter if it's the, you know, clubs first and then the spade or the spade and then the clubs. Like, it doesn't matter in the order of that, right? So this is a combination question. And yeah, so let's just say, well, how many aces are in the deck? There are 4 aces in the deck. And we're going to choose 3 of them. Okay, so there's that many ways that we could choose aces, right? But then we also have to multiply that by the number of ways to choose 2 kings. Okay, so the number of ways to choose 2 kings, there's 4 kings in the deck. And we're going to choose 2 of them. Okay. And then remember, we multiply those. We multiply a number of ways. Okay, so that's my favorable. And now the total is just a 5-card hand, like any 5-card hand, right? So that's just going to be, of all the 52 cards in the deck, we are going to choose 5 of them. And that's it. So that would just be, okay, well, there's 24 ways that we could do this. And then, yeah, lots of ways that we can choose a deck. Okay, and that ends up being 0.0000092, or 0.00092%. Okay, last one, because this is a pretty kind of a common one. So this is actually similar to the question we did in the last lesson there, but we're just going to kind of throw like a probability question into it now. So it says in a group of 11 students, there are 5 females and 6 males. How many different 4-member committees are possible if there must be at least 1 girl? All right, so let's try to get our bearings again on this one. So in this case, right, it's going to be, well, what if there was no restrictions? So no restrictions at all. Okay, well, that would just be of the 11 students, right? We're going to choose 4. Right? That's if I don't care who's a boy, I don't care who's a girl. And yeah. So now the way I'm going to do this one is we're going to say, okay, number 4 of Christian committees, and there must be at least 1 girl. Well, I'm going to take the total. And I'm going to subtract the situation where there are no girls, right? Because that'll be at least, like, this situation would be at least 1 girl is what I'll be left with. So, yeah, this is going to be no girls. Okay, so that's going to be, well, of the 5 girls, I'm going to choose none of them. But then I have to multiply that by the number of ways I can choose the boys. So of the 6 boys, I'm going to choose all 4. Okay, there you go. So this was like a nice, easy way, just writing it out this way. We end up getting 315. Instead, well, the other thing we could have done, right? We could have actually just added up all the situations. If you really wanted to, that's fine. You could have said, okay, of 5 girls, we're going to choose 1. And then you'd have to go of the 6 boys, we're going to choose 3. And then add that to of the 5 girls, we're going to choose 2. Multiply that by of the 6 boys, we're going to choose 2. And, you know, keep on going until you get all the situations with at least 1 girl. I just did it with the indirect method because it's a little bit quicker and easier if you get used to it. So, all right, so that's it. So there's 315 ways. Now I just want you to recognize that it can be written in this other method too, right? With 11 over 4, that means C, right? Those mean the same thing. Okay. All right, so that's it. That's the number of ways that can happen. Now it says determine the probability that a 4-member committee chosen at random from this group will consist of at least 1 female. Write your answer as a percent. Okay, well, we're kind of good already because we already found the number of ways that we can choose at least 1 girl, right? So that's our favorable. So if it's favorable over total, then our favorable was 315, right? That was the number of ways that we could choose 1 girl. And you could write it all out just on top like we did before, right? That was just the same equation that I had written above. And then that's just going to be over, well, the total, right? And the total, again, is just going to be 11, all the people, and choosing 4. That's not caring about who's a boy and who's a girl, right? That'll just be all the different ways that we could choose 4. Okay, and then if we want it as a percentage, we can just right now multiply by 100%, which is 95%. So 95% chance that that'll happen.